Well, for this talk, I'm going to be making the assumption that some people in here don't have the traditional computer science background, and that a lot of these chat programs on the internet are not magic, and I'm going to deconstruct a couple of them. So the topics are going to stay easy and then get more complex, but they all come down to the same core concept. Okay, WebSockets has four things they need to do. Okay, they need to make a connection. They need to close that connection after it's finished. They need to send a message and send a message and send a message and receive a message. So that's typically what they're built for. The messages can have 4,000 characters in their message buffer. So that's typically by default. If you want to override the defaults, you can have larger messages. So,
not to interrupt you, Jeremy, but did you have slides or?
I do. Let's see. I also have notes, and instead of let's see, I have some sentences on a notepad right now. So let's see. I will share my screen in just a moment. So the important thing for this talk is not the messages themselves, but what format they're in and how we use them in different contexts. So WebSockets are an abstraction level above the sockets library. Sockets library is low-level I/O, things like light switches and heart rate monitors, but this is streaming data. So this is different from other libraries that you might have used. So requests or URL lib. Requests asks for data in one swoop and receives that data all in one transaction. So we're going to be going with streaming data for this particular talk. So let me find out where that share screen thing went. All right. And all right. So this is a simple one. So can everybody see the programming screen?
Yes.
Okay, I just switched. All right, so I'm just going to run my Echo server. This is the simplest explanation, and all I'm going to do is be able to get data back. So, and this is using a library called Simple WebSocket, and the Echo 2 is using the same one. So all I'm saying is hi, and I can get hi back. All the server is doing is taking that message in line 14 and sending it back on the same connection in line 15. So sorry. I don't know how to get that to go away. All right. There we go. So in Echo 1, it says that it's running on HTTP, with localhost port 5000. That's a lie. If you try to go to that, it's not found. It's using a transport mechanism and a URL that's different. So in the client, you'll be able to see this kind of URL. It's WS : with localhost in the port name and whatever web service you want. This is the only way to tell the difference between a client and a server, because they're not that much, they're not that different. They still have to send and receive messages and open and close connections. So that is the server. It's just going to start a simple WebSocket connection. So only difference between, I mean, the code is very simple, less than a paragraph. All right. Okay. Is there an async version of this? And the answer is yes, there is an async version. So you can have these. This should be a little bit faster. This should be about 100 times more performant, I've heard. So this is using a library called Websockets, and it does the same thing. This is the server. How do you know it's the server? Because it's starting up a server and saying, I want to be called localhost running on port 8765. And the client doesn't look much different. There's an async def hello, and you specify the URL, and the URL is still this WS. This shows, just like HTTP and HTTPS, if there was an extra S on there, it would be a secure connection. So how do you make it from a, let's say, a non-encrypted to an encrypted? You add these 3 lines in. And inside the server, you put SSL is equal to SSL underscore context. And that's about it. Let's see. Oh, yeah. There are plenty of features with these. In Flask underscore socket.io, it has things like you can make your own, or you can make rooms. So join a room, leave a room. That way you can make your own IRC server. You can make your own connection with on websites. I'll say, we'll talk about that in just a minute. But each one can have their own chat area so that they can talk with your customer service representative. So, and I'll say all of these are the socket.io decorators are what makes this possible. Let's say to be able to group these rooms together. So I forgot. Okay, you can connect these things with web pages. So here is an example of a server. Not very much code again. And we'll run that. And so you can have a connection to a web page. Now, what is this doing in the background? You can see that it's an HTTP localhost, but it's not using HTTP to send these messages across. It is, in fact, using this WS or WebSocket protocol inside JavaScript. So do be aware how you're sending this information across. From that, you can make your own Slack or WeChat clones. Let's see, something I found out that's pretty common amongst the documentation is whenever you have documentation like this, let's see, SYN, AC, these are the network, let's say, transmissions that need to happen. You might see something like this. Let's see, after you've, if you're writing documentation that includes something like this, you've lost something. And it is not something that you can get back very easily. It's the person's will to live. So if you are writing documentation for this, please don't use these kind of connections. It doesn't tell the person what's first, what's next. This is hierarchical, it's going down. But it would be useful to be able to link this with the code that's actually running some of this stuff. I think that's an element missing in quite a lot of documentation about this. What else? Those messages that we've been dealing with have all been text messages up to this point. And so we're going to deal with one more. Let's see. Where is it? There it is. This is PubSub. PubSub is a way that you can subscribe to a series of messages across multiple browsers. So let's get this one running and start up a couple of these. So right now it sees that I'm online, and I can increase this count to whatever I need. Other people can also connect to that. I will do another window. So it keeps the state on the server, and it will broadcast out to all of the web clients. Now this is streaming data. Let's see, it is not your typical response. Let's see, your typical requests type of response. So that's WeChat, or how WeChat or Slack work. All right, we're going to take a look at different types of information that can be sent across our JSON messages. And this is an example for Coinbase. If you want to be able to get subscription to any type of cryptocurrency, then you can use a URL, this WSS, making sure that it's secure, from Coinbase. And it needs to do those 4 things. So it creates, let's say, a place internally where it can keep the state. Whenever you start a connection, it connects, listens. After you finish it, it will disconnect. It's just a wrapper around those very simple socket, that very simple socket library. So if you ever get a message, it needs to do that message processing. And what I did was I went ahead and made a wrapper around that. Let's see, actually I've got it up and running already. So I had to put this in Jupyter Notebook. Now you can put different types of things in those messages. In this, it's a little bit different. Whenever you start up the graphing WebSocket client, it creates a stream, a source stream where all of this data can be kept. Inside, we're going to put data frames instead of normal, JSON responses or text messages or something like that. So in order to do that, I needed to give it a type of data frame. So this is the pandas data frame that I'm going to send in, and give it a sample. This data frame that I have down here is not the same type. It's from streams. So it's a streaming data frame service. And so that's going to be kept internally. And we're going to be able to see, if I start this up, we're connected. And we're going to be able to see the table. What is this of? Ethereum's current price. And so I'm just watching it stream by. But actually, with streaming data frames, one of the nice things you can do is you can chart these. So instead of saving it to a database and then having to query it later, it's constantly streaming this information in. And let's see, being able to plot it out. Anyway, let's see. All of this, oh yeah. Some of this is, rather beta software, and so your mileage may vary. Anyway, it will break Jupyter. It will. I'm trying to figure out another way to display those, except or outside of a Jupyter Notebook. But anyway, that's about it. I think that is going to be it. Anyway.
Hey, Jeremy, does it break Jupyter Notebook because it's refreshing too quickly?
It shouldn't. Let's see. It's not that much data. Let's see. I was just getting Ethereum, and that was the only ticker item that I was querying for. So it shouldn't.
Very cool stuff. I was thinking you could do like a sleep 10 or a sleep 15 or something.
Oh yeah. Let's see. You can. Let's see. If I wanted to miss messages, then yeah, you could do that. But I wanted to get all the messages in, and whenever it came in, let's say, process them immediately. In that case, it was graphing, but you could send it to a database and for querying later, things like that. You can also make a buffer object and be able to do things like the min and max values over a certain time limit, over the last hour, or the mean, or how is it comparison to the mean value of the last hour. Those types of calculations, and be able to see that in real time.